Okay, these are now going to be equations that are going to use a combination of factoring and substitution and factoring, and then substitution and extracting roots. And so, again, I really enjoy using these different methods to solve equations. So let's just get started. So the first one we're going to factor. First, let's pull out a u. And so we get u to the fourth minus 16. And we need to remember that a squared minus b squared equals a minus b times a plus b. And u to the fourth is a perfect square, and 16 is a perfect square. So this becomes u times u squared plus 4 times u squared minus 4. Now, u squared plus 4 is prime, so it can't be factored anymore, so we're done with it. But u squared minus 4 can be. So, again, we're going to use the same factoring rule, and so we get u times u squared plus 4, and then we get u minus 2 times u minus 2. And this equals 0. So now, like we said before when we did factoring before, if I had a, so let's not use a. So say that I had x, say that I had m, n, p, and q equal to 0. If I had those 4 letters equal to 0, then I know that m equals 0 or n equals 0. Let's write this a little differently, just so you know. I know that m equals 0, n equals 0, p equals 0, or q equals 0. So I know that one of each of these 4 factors, at least one of them, equals 0. So that tells me that u equals 0, u squared plus 4 equals 0, u minus 2 equals 0, or u minus u plus 2. Sorry, that should be a plus. So this should be a plus, and so this is a plus. All right? So now I get to solve each of these. Well, the first one's done. So this is u squared equals negative 4. So u equals plus or minus 2i, because I take the square root. How I get there is I get u equals plus or minus the square root of negative 4. This is u equals 2, and this is u equals negative 2. So I have 4 solutions. Actually, I have 5 solutions. 1, 2, 3, 4, 5. So I have 5 solutions. My highest power was 5. Now I need to check those 5 solutions. All right? Now notice that I'm not just throwing my work any which way. I'm making little boxes or areas on my paper so that I know what I'm working on. So I have 0 to the 5th minus 16 times 0 equals 0. So that tells me 0 equals 0, so I'm done. Notice also that I went all the way to the end to show that 0 equals 0. I didn't just stop at the line above. I want to be complete in my answers. All right, if I have u equals 2, then I have 2 to the 5th minus 16 times 2 equals 0. Well, 2 to the 5th is 32, minus 16 times 2 is 32, so that's 0 equals 0. And I know that 2 to the 5th is 32. That's not something I've figured out. It's one of those I just know because I've used it for so long. I also have a minor's degree in computer science, and it's bits. So it's one I've used for a while. You will learn different facts like that that you will pick up from using them. So, again, putting in -2, I get -2 to the 5th is 32. Is actually -32. -16 times -2 is +32. So again, I get 0 equals 0. Now, how to do u equals 2i? I get 2i to the 5th minus 16 times 2i equals 0. Well, 2i to the 5th is 32 times I to the 5th minus 32i equals 0. Well, I'm going to go over here again to the side. So I to the 5th, that's I squared times I squared times I. Well, I squared is -1 times -1 times I. So that's -1 times -1 is +1. So that's going to be 1i, which is I. So this is 32i minus 32i. So this is 0 equals 0. So again, I complete my question. I don't just stop once oh, well, I can see right here at 0, I can see at this line at 0 times 0 minus 0, so I'm done. No, go along and make sure that your answer is complete. Remember, you're going to be a teacher and you want your answer to be complete. If you're not in this class to be a teacher, or if you're listening to this video because I've used it for another class, then whatever your major is, if your boss, you don't want to turn in shoddy work to your boss, and you want your work to be complete. It's a good practice to get into now, because otherwise it could bite you later. All right? So now we have -32i to the 5th plus 32i equals 0. So we get -32i plus 32i equals 0. So 0 equals 0. And we're done. Yay! So now let's go on to see how to do the next one. The next one uses substitution. Yikes. Turn that up. Pull that up just a little bit. So the next one uses substitution. So what we're going to do is, how do we know what to substitute? I'm going to let y equal either x to the 1/2 or x to the 1/4. And how do I know which one to let it be? The way that I'm going to do this is I want ax squared plus bx plus c equal to 0. I know how to solve that thing. The other thing I need to remember is that if I have a to the m to the n, that equals a to the m n. That I multiply, right? So then the question is, what is 1/4 squared? Okay? And what is 1/2 to the 4th? Okay? So I've got to figure out which one of these is working for me. Which one makes sense? So that one doesn't make sense. So 1/4 squared is going to be 1/4 squared is 1/2, right? Because that's going to be, how do I say this? This is so if I have 1/4, I'm writing this wrong. If I have x to the 1/4 and I want to square it, that's what I'm trying to say, then that's going to be x to the 1/4 times 2. So what is 1/4 times 2 over 1 is 1/2. Does everybody see that? If I can make sure I'm saying that correctly now. So if I have x to the 1/4 squared, that's x to the 1/4 times 2, which is 1/4 times 2, which is 1/2. Does that make sense? To have it that way versus having it a different way? So I'm going to let y equal x to the 1/4. So y is going to be my middle term. So then what I'm saying is I have 2y squared plus y minus 1 equal to 0. So this is the quadratic that I'm going to solve. So that I get rid of and don't worry about that x to the 4th power until the end. All right, if I solve this quadratic, so now let's think about how to solve this with the AC method. So what's 2 times 1? So 2 times 1 is 2. So I want two factors of 2 that subtract to give me 1. So of course it's 2 and 1. But I want that middle term to be positive. So I'm going to do this as 2y squared minus 1y plus 2y minus 1 equals 0. Because I want this right here to be a plus sign. Then I'm going to group these two together. So out of the first parentheses I pull a y, and I get 2y minus 1 plus 1, because I don't pull anything out, 2y minus 1 equals 0. Now I'm going to pull out the 2y minus 1, so I'm going to have 2y minus 1, and I'm left with a y plus 1 equals 0. Again, I set each factor, so I have 2y minus 1 equal to 0, and I have y plus 1 equal to 0. So this tells me 2y equals 1, so y equals 1/2, and y equals negative 1. Okay, but that's y. That's not x. I'm solving for x up here. Okay, so then I need to say that if y is 1/2, then that's x to the 1/4. So how do I get that? I'm going to multiply this by 4 to find what x is. So x equals 1 over 16. And if y equals negative 1, then x to the 1/4 equals negative 1. So I raise that to the fourth, so x equals 1. Now, here it's very important to check your solutions, because in order to solve this question, remember, I created a new equation. I created that y equals x to the 1/4. So I'm going to check x equals 1/16. So 1/16 to the 1/2 plus 1/16 to the 1/4 minus 1 equals 0. Notice I'm going back into the original. If I put them into the factored version or into the y version, yes, they would work, but I've got to put them back into the original. So I get 2 times 1/4 plus 1/2 minus 1. So that's 1/2 plus 1/2 minus 1 equal to 0. So that's 1 minus 1 equals 0. So 0 equals 0. So yes, that checks. What about x equals to 1? 2 times 1 to the 1/2 plus 1 to the 1/4 minus 1. Does that equal 0? So that's 2 plus 1 minus 1 equal to 0. So that's 3 minus 1 equal to 0. That is no solution. So this x equals to 1 is not a solution, but x equal to 1/16 is my only solution. That is why it is important to check your solution. Okay? Now let's go on to the next one. And the next one, we're actually going to use extracting roots. So the first thing we're going to do is we're going to say x minus 7 equals 4/3, and we're going to have 81. Now what we're going to do is we're going to raise this to the 3/4 on both sides. Okay? Now, here's the trick. I'm going to go over again to the side of my paper, and this is where scratch paper comes out. And I don't know if y'all have noticed, and I'm going to say y'all like I'm Southern, because I am Southern, that y'all have noticed I like not using a calculator. I came through school without using a calculator, so I do not go to calculators a lot. So I'm going to go over here to the side, and I'm going to show you that I do not need a calculator to work this question. Okay, 81 is 9 times 9. 9 is 3 squared. All right, so this is 3 to the 4th. All right, so I'm going to rewrite this as x minus 7. This is x minus 7 equals 3 to the 4th to the 3/4. Those 4's will cancel out, so this is x minus 7, 3 cubed. So this is x minus 7 equals 27, so x equals 20. Undo. X equals 34. If I can add, which will be funny. All right, and then we really simply have to check our solution. So x equals 34. So x 34. So 34 minus 7 raised to the 4/3 equals 81. So 34 minus 7 is 27 to the 4/3 equals 81. So The cube root of 27 is 3, so that's 3 to the 4th equals 81. And 3 to the 4th is 81, and we are done. Please email me if you have any questions. Thank you.